Hello and welcome to this video lesson. In this video lesson we will cover the basics of vectors. Let's start with a simple scenario. We got James and Carol. They just started dating about a month ago. They are now about to hike, and James, as they're walking, sees a very nice tree and he gets very distracted and moves towards it, while Carol just walks away with her earphones in her ears, not really realizing what is happening and that James has just gone to see the tree. After enjoying a little bit of oxygen from this beautiful tree, James all of a sudden turns around and figures out that, where did Carol go? And then he wants to contact Carol, but he looks at his phone and realizes that the battery is low. After panicking a little bit and realizing that, this relationship might not last that long, he looks at his pocket and realizes that he got a walkie-talkie. And obviously he's very happy because he knows that Carol is also carrying a walkie-talkie. So he tries to contact Carol using the walkie-talkie, when all of a sudden a very cute monkey appears out of nowhere. And when he contacts Carol, he says, "Where are you? I have to show you this very cute monkey." But James is kind of out of luck because the monkey all of a sudden turns into an evil monkey carrying weapons in both hands. James is panicking once again, but this time he's not as worried that his relationship is about to end, but is really worried that he's about to die. Carol finally hears some voice coming out of the walkie-talkie and realizes that James is nowhere around her, and she tells James, or asks James, that, "Are you still in front of that big tree? And now you're being chased by an evil monkey? Well, you should." Now here Carol has to be very careful with her wording, because if she gives a direction which is not very clear, James could be no more. Let's look at some options that could cause a very dark ending to this story. Very close to Carol, there's a giant flower, and one option would be to tell James to come by the giant flower. One option is a very clear option, logical option, but not very kind. She could simply just ditch James. And another option that could lead to a very dark ending for James would be for Carol to just say, "I am 500 meters away from you, hurry." And obviously the first two options are not very meaningful for James, but the third one is actually not too bad. She is 500 meters away. But the only problem is that James will not know in which direction he has to move, and that is problematic when he is being chased by an evil monkey. So let's look at some options that could get James in the right direction and maybe not a dark ending to the story. Carol could simply say that she's 500 meters away in the direction of northwest. This gives James a good idea of where he has to go. James doesn't have a map, but luckily he does have a good sense of northwest, east, and south. Instead of giving James a distance and a direction, she could break that distance into two components and tell James to go 350 meters north, then turn and go 350 meters west. The last option takes a little bit of time to communicate, but sometimes when you think a little bit more, you always get the best solution. So she could divide that distance into a little bit more components. So she could say, go 140 meters west until you see a giant tree, then go 140 meters until north until you see the river. And this way, James kind of has an idea of where he's going. Finally, jump into the river and swim for 210 meters west. And everybody knows that evil monkeys can't swim, so he's no longer being chased by a monkey, so Carol really helped him there. Then when you see a treehouse, jump off and travel 210 meters north, and you will see me. Okay, so the scenario kind of gives us an idea about the fact that if we are giving direction to somebody, we need to kind of give them a distance of how far we are from them, and also a direction. Otherwise, they would not know where we are. So scalar quantity only has a magnitude. So examples of those are distance, energy, mass, volume, and there are other examples as well. But distance was one that we saw when Carol told James that she is 500 meters away from him. James did not really know where to go, but vector quantities have both magnitude and direction. So example of a vector quantity is when Carol told James to go 500 meters in the direction northwest, or when she said go 210 meters north or 210 meters west. These all have a magnitude and a direction. Other examples include but are not limited to things such as force and velocities. Now let's take a look at how we can represent vectors. So vectors are simply shown by an arrow. In this case, or in this example, we have a vector that starts from point O, or the origin point, and goes in the direction of A. The magnitude is 30 kilometer, and that magnitude is kind of shown by the length of the line segment. So the bigger it is, the higher the magnitude. The smaller it is, the smaller the magnitude. The arrowhead of the vector shows us which direction it's going to. And in this example, we added 47 degrees to give us an idea that the arrow is pointing in the kind of in the direction of northeast, but it's actually very close to northeast, but it's 47 degrees east of north. Now, for this example, where the vector starts from the origin and continues to point A, we call it a position vector of A. So position vector of A kind of looks at where point A is, where the origin of our coordinate system is, and the position vector kind of always starts from our origin. The position vector of point A can be represented by the following symbol. So you can write it as OA with a vector sign above it, or you can write it as A with a squiggly mark above it, or you can write it as A with an arrowhead above it. So this kind of says that A is the vector, and when you write it as OA, it says for the starting point and the ending point is, but you gotta make sure that you put that arrow on top. Its magnitude, you can use the modulus function to represent it, or you can just write OA without the arrow sign, or you can use the modulus sign again and say it's vector A with a squiggly mark on the top or an arrowhead on the top. Now, if our vector doesn't start from the origin, in this case, we have a vector that starts at point A and finishes at point B, we say that the vector AB, we gotta make sure that we include the arrowhead on top, because if we don't, that means that it's the magnitude. We say that this vector originates at A and terminates at B. This vector is a position vector of B relative to A. So it kind of shows position vector of B starting from another point A. Now, if you have two vectors, those two vectors will be equal if their direction and magnitude is exactly the same. So for this to happen, if we draw them out, you will notice that they are parallel. They're pointing at the same direction and that their magnitude is the same. You can also note that their position doesn't really matter. It doesn't matter where they start. They are equal as long as they have the same direction and magnitude. Now, if two vectors have an equal size and are parallel, it doesn't necessarily mean that they are equal, because they could be pointing in opposite directions. So here we have an example where we start a vector from point A and we go to point B. So we have vector AB, and if we start from B and go to A, we will have vector BA, which definitely has the same magnitude because the distance between A and B is the same, but it is pointing at different direction, and they are parallel as well. Now, if this is the case where we have vector AB and BA, they would have the same magnitude, but they would have different or opposite directions. And we say that BA is the negative of AB, and thus we can write it as vector BA is equal to negative vector AB. Let's look at an example here. Here we have a rectangle ABCD, and we can write that vector AB is equal to negative BA, which is equal to vector DC and negative CD. And if we look at the other sides, we can say that vector AD is equal to negative DA, which is equal to vector BC, and that is equal to vector negative CB. Now let's look at how we can add vectors. So we had an example where Carol told James to go 350 meters north and then 350 meters west. So for this we have two vectors, and if we kind of want to see the resultant vector, we need to add them. So we can set vector AB to be 350 meters north, vector BC to be 350 meters west. And to add what we do, step 1 is to draw vector AB. Step 2 is at arrowhead of AB or point B, draw vector BC. And finally join the beginning of vector AB, which is point A, to the arrowhead of vector BC, which is point C. And this will be vector AB plus vector BC is equal to vector AC. So looking at the diagram, first thing we do is we draw vector AB, which is 350 meters north. Then we add vector BC on the arrowhead of AB, and then we draw the resulting from point A to point C. Let's look at a few examples. So our first example, we have vector AB. We want to add it to vector BC. And again, we start from AB. We add BC to the arrowhead of AB. And we draw the resulting vector from A to point C. In our second example, we have vector WX. We add vector XY to it, and we draw the resulting vector from point W to point Y. Now, let's take a look at how we can subtract two vectors. So, let's say we're subtracting vector B from A, so A minus B. We can write that as A plus negative B. So, to do our steps, to subtract vectors, we add its negative. So graphically, we can draw vector A and vector B. This is how we would add them. And to subtract them, we change B to negative B. So we just draw the same magnitude, but exactly the opposite direction. and then connect the beginning of A to end of negative B, and that would be vector A minus vector B. Now, zero vectors are vectors with magnitude of 0. To represent a zero vector, we put a 0 with an arrow on top of it. So if we add any vector to 0, we get itself. So A plus 0, vector A plus vector 0 is equal to vector A. And if we subtract a vector from itself, we get 0. So for example, vector A plus negative A would equal to vector 0. Let's look at an example now. So in the first example, we are to construct the vector equation for the following shape. The shape has 5 sides, or is consisted of 5 different vectors. Vector A, B, C, D, and E. And you can see the direction of the vectors and their magnitude from the shape. In the second diagram, we have a parallelogram, and it has vertices A, B, C, and D. And vector BA is called vector A, vector AC is called vector B, and vector CD is called vector C. For the second question, we want to find vector AD in terms of vector A, vector B, and vector C. So for the first example, we're going to look at vectors that are going the same direction. So vector A, B, and C are kind of from tail to head, tail to head, tail to head. And then vector E and vector D is also from tail to head. So what we can do is we can say vector A plus vector B plus vector C is equal to vector E plus vector D, because their starting point and their ending point is exactly the same location. And we can rewrite that vector equation in terms of one of the vectors, and there's many alternatives of doing this. So here we can say that vector E is equal to vector A plus vector B plus vector C minus vector D. And all we've done in this step is to rearrange the formula and subtracted vector D from both sides of the equation. For the second example, we're trying to look at vector AD, and we know that vector AD starts at A and terminates at D. So we can look at which vectors start at point A, and that's vector AC, and we can draw an arrow in that direction from A to C, and we can see that from C, if we go from start from C and terminate at D, we actually get vector AD. So we can write the equation as vector AD is equal to vector B plus vector C. Now let's look at scalar multiplication. So scalar multiplication simply means multiplying scalar value, which only has magnitude and no direction, by a vector. Looking graphically, we can see if vector A has a certain magnitude, 2A, or 2 times vector A, would have twice the magnitude, but it will go in the same direction. Vector 5, scalar value of 5 multiplied by vector A would have 5 times the magnitude of vector A, but it goes in the same direction. And finally, if we multiply it by a value such as -4, it will have 4 times the magnitude, but the opposite direction of vector A. Now, writing a summary of that, if we multiply a value of k, which is a scalar value, by vector A, if k is equal to 0, then k multiplied by vector A will give us a 0 vector. If k is larger than 0, then the magnitude becomes ka, and it goes in the same direction of vector A. And if k value is smaller than 0, then the magnitude is ka, but it's in the opposite direction of vector A.